class. Good afternoon, good evening, good morning. Welcome back sa tuang class. This will be a continuation on our discussion sa electrostatics, particularly on we are now on work and energy in electrostatics. Okay, so I hope so far nasabtan ra ang mga discussions na to regarding electrostatics and electromagnetism, and I hope you're enjoying so far. And if you have questions, if naamoy mga naging questions nga you think makatubag ko, then you can just freely ask me sa katong Facebook na to nga group chat, or pwede ko ninyo i-email, or you can actually pwede po ko ninyo i-text. You have my personal contact or contact number. Okay, so let's continue. So we are now on work and energy and electrostatics.
Sir, excuse me.
So we are now on work and energy and electrostatics. So first, we consider a point charge Q1 sitting at the origin. And then a point charge Q2 is moved from infinity to a distance r sub 2 from the origin. So we will assume that the point charge Q1 remains fixed at the origin while point charge Q2 is moved. So it's like this ang scenario. Let me just quickly draw it. Okay, let's say you have your point Q1 here, and then there's this point charge Q2 at a certain distance, in this case a distance R2. Okay. No, sorry. So it's like this is where your charge Q2 is located originally, and then it is moved at a distance R2. Okay. So when you do this, when you move a charge Q2, let's say the charge is of the same ang iyang magnitude and same ang iyang sign, then there must be some kind of a force opposing the two, because this charge Q1 is emitting an electric field, let's say in that direction. This is a positive charge. So you need an energy for you to bring this charge Q2 from its origin to a certain distance, let's say in this case r sub 2. Okay. So there is a force exerted by Q1. Of course, there's a Q1 will exert a force towards Q2, and that is equal to, we know this formula, right? So this is the force acting on Q2 by charge Q1. So, or force that is caused by Q1 towards Q2. So, muna siya ang formula. Have your charge Q2 and then the electric field of the charge Q1. So, in order to move Q2, we will have to exert a force opposite to this force, right? Opposite to this force. So, when you calculate that one, we actually get the work done, because we are bringing charge Q2 to a certain distance, and then there's this force opposing that charge Q2 because of this charge Q1, and then it involves also a distance because there is a force, and then in that manner there is a distance nga imuhang traverse when bringing Q2 to a certain distance. So that formula is actually the definition of what a work is, right? Force times distance. Now let's say our reference point for the charge Q2 is gikan siya infinity, and then we bring that charge Q2 to a certain distance, say r sub 2. And negative because it's opposing man siya, opposite ang imuhang the direction of the electric field and your charge Q2. So opposite ang force na gi-exert. Okay, so we have this formula. If we substitute F sub 1, 2, which is given by this equation. So we get this form. And we recall in our previous discussion that this is actually this one. This is actually your equation for potential, right? Because we have our formula for potential. Ano man to, diba? A to B, and then E dot dl. So this is actually potential. So your work now, or that is the work needed, or the work that must be done to move Q2 from infinity to R2 is equal to this formula. So dependent na siya sa charge Q2 kung sa ito imong gi-move, and the potential nga, ang potential due to this charge Q1 at a certain distance, which is R sub 2 in this case. Okay, so we have this formula. Ako, gina-write lang siya. So using the equation of V for a point charge, the work W can be written as, manaaman tayo formula sa katong V in our previous discussion. Our formula for V is katuman ng ano, diba? 1 over 4 pi epsilon naught. Then Q, let's say Q sub I over R sub I. So we have this formula for V. I-substitute nimo siya diha, we get this equation sa imuhang work. Now, this is for the case wherein duha ka charge, right? So, nakoy charge Q1 and then nakoy charge Q2. Unsa man ang work needed para ma-assemble na siya ba? Para ma-assemble ni Q2, gikan siya from infinity, tapos gi-bring nimo siya at a distance R2. Okay, kana siya. So the work W is the work necessary to assemble the system of 2-point charges. And that is what we call the electrostatic potential energy of the system. Okay? So the energy needed para ma-assemble na siya or ma-combine. So it's like forming an atom or forming a molecule. So what sa may work needed, or so simply put, electrostatic potential energy, or energy in short. Energy para ma-form na nimo nga entity, let's say an atom or a molecule maybe. So the energy of a system of more than 2-point charges can be found in a similar manner using the superposition principle. Let's say kung tulo na kabuo, unsa ka ang energy or work kailangan para ma-assemble na siya. So naa na siya distance R1, let's say R1 na siya, then this is R2, then this is R3. So the same yapon ang principle buhaton. We will be using the superposition principle wherein ang energy needed to bring this whole thing together is independent of each other. Independent siya. So, pwede ka nga, usugod ka ana, tapos pila kayo work kailangan para ma-bring nimo ang charge nga kana. Tapos, sunod na po, if wala na siya kunuhay, pila ka ang energy kailangan na po para ma-bring na siya. So, isa-isahon nimo siya, the superposition principle, and then you add everything, you get the W of the whole system. So it's like this. You have this system of 3-point charges. So this is labeled as R1 and 2, the distance between Q1 and Q2. R1 and R13, the distance between Q1 and Q3, and so on. Okay. So the electrostatic potential energy is equal to this one. So superposition principle na siya. So ang formula man natong ang formula sa katong duha ka point charge is like kani, di ba? If nagdugang na ka og Q3, so imo ra siyang it's like nag-combine ka ani. That's why you have Q2, Q3 kana. Tapos kani pud siya separate Q1, Q3 that napo kay Q1, Q3. So tulo na siya ka possible combinations, okay? Okay, di man pwede magbalik-balik. Let's say Q2, Q1 is the same sa Q1, Q2. Q3, Q1 the same sa Q1, Q3. So we only have these 3 possible combinations sa imuhang energy needed for you to assemble this system of 3-point charges. But how about if we have more than 3-point charges? Let's say 5, pwede po 10, pwede 15, or it could be any arbitrary number n. Okay? N charges. So we can generalize that one by having this formula. So isam ra nimo siya. So this formula is very simple and useful because it really captures the when you want to calculate the work needed for you to assemble n-point charges. Okay? So gisam ra man nimo siya. This is the katong uh, the first charge, and this one is the other charge. Okay? So it's a I runs from 1 up to n, and j also runs from from I plus 1 up to n. So the reason nga I plus 1 na siya para wala kay magbalik-balik. Kay example, atong so ayan, kung tulo lang kabuok, tulo ang imong n kay 3. Okay? So let's say n is 3, so sugod kag I equals 1. So you have your q1, and then j runs from I plus 1 man siya ang j. So muad kag isa. So we have q2 over r12 plus, so q1 gihapon, right? Kay mas siya for loop pa. This is your row, this is your column. Okay. So q1, so 2 naman na siya, so 3 na din ka. r13. Okay? Since wala naman tayo 4, kay n is 3 naman, so stop na diha. Next na po nga iteration is sa q1, so q2 na punta. q2 then, since ang j is I plus 1, so this is q3 over r23. Kung napabay plus, so pwede ta mag q3. But since q3, wala man tayo q4, right? So wala na. So actually, diha na siya mag-end. Tulo lagi siya pwede. So this formula actually is correct. This is the general formula for calculating the work needed for you to assemble an arbitrary number of charges, say n. As I've said, the lower limit of j equals I plus 1 ensures that each pair of point charges, sakto ba ng spelling sa ensures? Okay. Oh, anyway, ensures that each pair of point charges is only counted once. So, muna akong na-mention kanina. So the electrostatic potential energy can also be written as, instead of having this, pilitan mo gamit ani. Okay? We resort to this equation because natin makuha ang meaningful formula, masimplify siya. So, kada siya, equal na siya ani. Okay? The same na siya. So, instead na ang iyang counting is j equals I plus 1, sugod gyapon ta sa 1 up to n. Provided that j should not be equal to I. Okay? If kanimo gamiton nga formula, I'm sure na agi magbalik-balik ana q1, q2, pinapik plus q2, q1. So, to avoid doubling of counting, okay, redundant siya, so natin 1/2 diri nga factor para mabalance na siya. So putana mo 1/2, so it's like wala ka nagdoble og count, pareha siya ani. Okay? Okay. So simplifying this one, so gigawas na actually ang q sub I. So that's why naadari ang q sub I because summation naman siya sa I. Wala siya ilabot sa j. So we have this formula here. Right? So you can actually notice, i-arrange na siya. Nga, kani siya nga formula, this is actually your potential. Kani. It's your V. Right? Pamana ang V. Imong formula sa V, potential. So, na-simplify mo ang works. Instead of this, you only have this equation. Okay? Masahin siya tanawon, right? Mas neat. We have 1/2 the summation of q sub I times v sub I, where I runs from 1 up to n. Okay? Take note of this formula. So you have this formula here. So when the charge of the system is not, so this is only true if ang imuhang distribution sa mga charges bitaw, like discrete siya, like ana ba. So nakay summation of Qi and Vi. But what if when the charge of the system is not distributed as point charges, but rather as a continuous charge distribution? Because in reality, charges are always distributed in continuous manner or fashion. Wala kakitag mga yun ana. So, nagsugod lang ta ana kay mas sayon man siya, diba? Mo sugod ta og simple case and then we go to more realistic or complicated case na dayon. Then the electrostatic potential energy of the system must be written as, instead of having this, so mahitabo is, so what will happen is your summation will become integral, and your QI will become dq, v. So mahimo siya ingon ana, and it will become like this. Okay, so take a look. This is the case for volume charge distribution. So this is volume. So your dq becomes actually rho d tau. Tama? Muna itong formula sa kuan. This is your volume charge density. Ang unit ana niya is volume, ang unit niya is charge per volume, right? And kani siya is volume. So multiply mo volume, cancel. Actually, ang unit niya is actually charge gihapon, which is this is actually charge. So for continuous surface and line charges, the electrostatic potential is equal to, so we have the counterpart for finding the work needed to assemble charges na distributed ang iyang charge over an area and over a line, where sigma is your surface charge density and lambda is your line charge per unit length. However, we can also, so take note sa kaning formula. This is muna siya ang formula to calculate for the work needed for you to assemble a system of continuous volume charge distribution, surface area, surface and air distribution. This is for line charge distribution. However, we can also get the same value for your work. Instead of getting the potential, you can also calculate the work by knowing the electric field. Okay? This is another method niya, a detour. So we recall that the charge density rho is related to the electric field. Check the formula. It's given by this. Ipa mao ni siya ang imuhang differential form sa Gauss's law. So actually ana siya. Okay, that's the differential form sa Gauss's law. And then to get the rho, we just simply cross multiply. So what ang naakuan? So using this relation, we can rewrite the electrostatic potential energy as this one. Okay, mamo na siya ang rho, di ba? Actually, katuning formula ganina. Where ang formula is 1/2 rho v d tau, where we substitute the expression for rho kani. So that's why naako aning equation. Okay, that's simple. And then imuhada man ni siyang distribute. Anyway, wala makigi-violate ani nga rule, right? So gi-derive niya, isumpay niya, and then this one, ihapong gibulag. So this is like chain rule. Imuhang gigamit ani nga formula. So that's why you have this equation. From this equation, nahimo siyang kaninga form. Okay? And then we use the formula sa katong divergence theorem. Then we have this from a volume to a surface area. Okay, and then this is E. So E ra na siya. So we have E dot E, that would be E squared. And then the first term approaches 0. Okay, so this is this one. So this actually approaches 0. Ang imuhang electric field integrated over the area. Okay, so the first approaches 0, this one, leaving us only with the second term. So the formula now for the work needed to assemble a system of continuous charge distribution is given by this. So natay duha ka way para ma-solve ang imong work. Either you use this equation, 1/2 integral of rho v d tau volume, or this one. So in either case, if given an electric field, given ang imong potential V, then you can actually get the same result. So let's take an example. This problem is taken from the book Griffiths. So a sphere of radius r carries a charge density rho of r. So equation niya is kr, where k is a constant. So find the energy of the configuration. So pangitaon nimo ang W. So check your answer by calculating it in two different ways. So itong two different ways, katong 1/2 rho v d tau o katong epsilon naught over 2 ba to? E squared d tau. Let me check. Okay. So we can calculate the work or the energy of the configuration sa kanang system by using these formulas, kaning formula 1 and formula 2. We should be able to get the same result. Okay, that's the solution using method 1. So we make use of this formula sa method 1 tong sa electric field. So in order for us to calculate the energy configuration of the system, we need to know first what is the electric field. Okay, balik ta sa question. Ang question is a sphere. So a sphere, so volume ni siya of radius r. Tapos nasa charge density which is dependent sa r, di siya constant. We have kr. Okay. So the electric field can be obtained by using the Gauss's law, of course, given by this equation, right? And we can actually, so this is the general formula sa imuhang Gauss's law. Okay, if you have your sphere, kasi ang imuhang Gaussian surface is nasa sulod, ang area sa Gaussian surface is actually 4 pi r squared. R is for arbitrary. The same thing po if ang imuhang Gaussian surface is nasa gawas. So that's actually small r gihapon. So ang ihang Gaussian surface ng mga area is actually the same. You have 4 pi r squared. So general lang mo na siya nga formula, okay? Where Q enclosed is given by this. Q enclosed okay, so the Q enclosed is given by this. You have your rho d tau, mamo na siya. Ang imong rho mo tong kr, di ba? Okay. So for the electric field inside, so small r is less than big R. So you have this. Kasi you have this formula, actually ana na siya. E times 2 pi r squared na imong Q enclosed kay ana man to. Kr d tau. So ang d tau nimo is you have actually 4 pi r squared dr, di ba? Mama na siya. So ang d tau nimo is ana man na siya. If we recall r sine squared sine theta dr d theta d phi. And ang imong d theta of d phi, that's actually 4 pi naman na siya. So mabili na lang is r squared dr. That's why na ako ani. If you do that, if you integrate this one, you actually get 4 pi r cubed over 3. Oh, this is r cubed man no? So this becomes 4 pi r to the 4th over 4. Okay, so mag-cancel ang 4. That's why imo siyang i-substitute din sa imong Gauss's law. So 1 over 4 pi r square katong sa kanisya during the pit. And then Q enclosed, your Q enclosed is just, simplify mo na siya, you have your pi kr to the fourth. Okay? Cancel man ang imong 4 din eh. So you have this equation na. So simplifying, you get this equation sa imong electric field. And that's for the inside. And then the electric field outside, so the same formula. Muna siya ang katong sa area bitaw nga part. Ang sa Q enclosed nimo is lahi na siya ka case kay you have outside man siya, so you have your sphere, this is your Gaussian surface. So ang Q enclosed nimo is painani na siya. Rho d tau. So we have kr 4 pi r squared dr. So from 0 to r na siya. Tama? So may mo din na siyang k 4 pi and then you have your r to the 4th over 4 from 0 to r. So this becomes k r cubed. K r to the 4th, I mean. K r to the 4th, okay? Pi, cancel. Kami naman ang 4 ang na-cancel. That's why na ako, ani. Okay? And you have your 4 pi r squared sa ubos, you get this expression sa imong electric field. So far, so good. So the total electrostatic energy can be obtained from the electric field. So imuha naman siyang isum nimo all space. So we have, your formula is given by this, right? All space. So a sum nimo actually is ang electric field, ang energy configuration sa inside. Okay, this is So this is inside. So this is inside, right, from 0 to r. And then, ang kanina contribution, this is all space man siya, so outside. This is actually from r up to infinity. Okay, ano siya ihang limit diha. So, if you have this sphere, so this is from 0 to r, and then from r to infinity. So, duha ka region. That's why I have this formula here. So, imo na siyang i-integrate. Simplify, you get this. The second term also, you simplify, you get this. And then you evaluate the integral. Sa'yo na muna siya because the simple rules yung pag-integrate, this is r to the 7. That's why na ako r to the 7 here. Then, and so on. Okay, this is r to the, this one. In terms of r squared. So, we have this is 1 over r. So, r to the 8, that cancel, that becomes r to the 7. So, now r to the 7. Simplifying further, we get this final form of the work. Okay, this is work needed to assemble the system. Okay, in our case, ang sphere ni siya. Solid sphere of radius big R having a volume charge density of kr. So you have this formula. We can also get the same result for work instead of using this equation, katong equation sa katong this one. Okay? So kailangan naman mo pagkitaon ng potential. So we get V from the inside of the charged sphere. Okay? So kani kailangan din gihapon nimo, so we have V ang imong electric field. So I think doble siya ang imong trabaho, right? But I think we should be able to get the same result. So this is the electric field. Potential ni siya. So potential is you come from a reference point which is infinity up to a location let's say R. Okay, let's say this is inside the sphere. So ang electric field niya is, this is electric field outside, and this is the electric field inside, right? So simplifying, and then you do the integration, you get this. And so the electrostatic potential energy, kani siya, mo na siya ang iyang potential. So getting the electrostatic potential energy or the work is given by this. Isa-substitute mo na siya din. You get this form, and then you just simply integrate, you get this one. This is actually the same result sa previous. This is the previous result. Tara. The same result na siya ani. Okay? So that is actually equal to the energy calculated using method 1. Now let's move on to metallic conductors. The same hapon, we will calculate the energy configuration of the system, and mas simpler lang din sa metallic conductors because of some constraint and limitation of having by virtue of metallic conductors. So in a metallic conductor, one or more electrons per atom are free to move around through the material. So metallic conductors have the following electrostatic properties. First is the electric field inside the conductor is equal to 0. Because if there would be an electric field inside the conductor, the free charges would move and produce an electric field of their own, opposite to the initial electric field. And these free charges will continue to flow until the cancellation of the initial field is complete. So in return, cancel out yung gihapon ang electric field, any electric field inside the conductor. That's why it's always 0. And the charge density inside the conductor is equal to 0. This is by virtue of property 1. By virtue of this. And then any net charge of a conductor resides on the surface. Since the charge density inside the conductor is equal to 0, so any net charge can only reside on the surface. So if you have any conductor nga imo i-consider, ang net charge will always be found sa surface. And the electrostatic potential V is constant through the conductor. We also call this one as an equipotential. So let's say if you have your conductor here, okay? Let's say gusto mo calculate sa potential din nga point A and potential sa point B. So you have your formula here. We can get the potential difference at B and at A. Ang formula ana is negative E dot dl. And since ang imong electric field sa conductor anywhere inside the conductor is always 0, so this is 0. So we have VB minus VA. Therefore, VB is VA. This would only mean na mo na siya nga postulate that the electrostatic potential V is constant throughout the conductor. Okay? The same ang value sa iyang potential. And the electric field perpendicular to the surface just outside the conductor, and the electric field is perpendicular to the surface just outside the conductor. There would be no tangential electric field component sa imong conductor. If naman gani, it will eventually be cancelled out. So let's have an example. Consider this example. Suppose we place a point charge Q at the center of a spherical shell, a spherical conducting shell. So in that case, it will attract negative charge to the inner surface. Okay, so we have, say, now, this is your shell. So a shell has an inner radius and an outer radius. So this is charge Q. So mo-attract ni siya og negative charge to the inner surface dinhi. Attract siya negative charge diha. The question is, how much induced charge will accumulate here? Okay. Next is, you find the electric field and potential as a function of R in these regions. R less than A, in between, and then R greater than B. Okay, katong kung doing ganina, you have your charge Q. So this is your spherical conducting shell. So this is A. This is B. So you find the potential and electric field inside, in between, and then outside. So you have this graphical representation here. So what is the electric field and potential at the following regions? Inside, and then in between, and then outside. Okay. First, for question A, question A, how much induced charge will accumulate here? So the electric field inside the conductor is zero. Yung mga ang property sa conductor. So ang electric field inside any conductor is zero. So we know that. Okay. So for B, mo na ba siya? Okay. What is 0.1? Okay. Then we have the electric field for the following regions. Okay. By virtue of Gauss's law, we have E 4 pi r squared times Q enclosed over epsilon naught. Okay. For the this is B less than R. Okay. So this should be So this should be tama. B less than R, or this is R greater than B. This is outside. So this is outside, in between, and then inside. Okay. So ang Q enclosed nimo is Q gihapon, right? And then since inside the itong sa in between, this is actually 0 because that's inside the conductor. Okay? Mamani mahang kuan charge. Tapos sa sulod, sa in between ani, this is inside sa conductor. So any electric field there is 0. So that's why 0 na siya. And then the same formula for the electric field inside for R less than A. Okay, arbitrary R. Then we can also calculate the potential V at this three different region. Okay, how do we do that? Let's calculate the potential. Say the potential at B less than R. So sa kaya potential niya. So the formula is actually this one. V of R equals negative. So our reference point nimo is always from infinity to R. Right? So E dot dl equals negative 4 pi. So say electric field sa gawas. Okay. So we have from negative infinity to from infinity to R. And then ang formula nimo is Q over R prime squared. So use prime kay R man din. So we have dr prime. Then integrating that one, we get 1 over 4 pi epsilon naught Q over R. So that's the potential outside. However, for the potential itong sa in between, A less than R less than B. So we still use the same equation. We have negative from infinity gyapon imong why always put negative. From infinity to arbitrary point R or distance, E dot dl. So in this case, duha siya ka region ang imuhang i-traverse. First is from infinity padulong sa surface gyud sa outer radius sa imong conducting ay imong spherical conducting shell. You have your Q r prime squared dr prime, then minus katong the same formula 1 over 4 pi epsilon naught. This time katong dayong from since ang imong B to A kay wala man kay electric field diha, so mo start na ka from A padulong sa sulod, which is small r, Q over r prime squared dr. Okay. So if you integrate this one, integrate mo na siya, you will actually get kamo na lay integrate ana sa inyong own convenient time, and you try to check if sakto ba ni the same tag makuha nga answer. 4 pi epsilon naught Q over B. So, wala na negative sa gawas kung palin sa sulod. Q over A plus Q over R. Okay, so you should be able to get this. Okay. Oh, na-over na ako ni, sorry. This is actually, ako na lang ikuan, na R less than A. Kina, naabot na ko pati sa sulod, right? Napadulong na siya sa, padulong na siya sa sulod, kini. So, for, katong in between, sa in between is, the same gyapon tag formula gamiton, pero ang imong limit na dayon is from negative, from infinity to B. So kana lang from infinity to B ang imuhang limit. Okay, from B to A, kay wala man na siya wala siya electric field, so wala siya potential, so zero ang imong makuha niya. So the same kaya kung Q over R prime squared dr prime, you get 1 over 4 pi epsilon naught Q over B. So muna ang case sa in between. Kani siya is katong sa R less than A. R less than A. Let's continue. Now, let's move on to the topic sa capacitor, from metallic conductor to capacitor. So, we know unsa man ang capacitor, right? Sige ta kakita og capacitor. Capacitors are present in almost, I think tanan siguro all electronic devices, your computers, your cell phones, your laptops. So, ang idea naman sa capacitor is simple, na ako'y duha na gina siya ka-plate, okay, of opposite charge. Si positive ang isa kay negative. So, that's the idea of capacitor. And then, interesting physics will come out from this. So, gamit kini siya sa kani idea sa capacitor in all electronic devices. Labi na sa imong cellphone, touchscreen nimo, ang screen actually is an area or a sea of capacitance or capacitor, wherein kuwante siya kanang sensitive siya sa imong touch. So even you touch certain portions sa imong screen, that actually sends signal sa imong phone. Diha nga part nag-change ang capacitance value. So, kada nga part, nakaibaw ang cellphone nga nag-press ka diha. So, you have this formula here. You can get the potential difference between them. If you have plus Q and negative Q on the other, we can get the potential. You have potential difference, V plus minus V minus. And the formula is given by this. The electric field dot with the DL displacement integrated from negative to plus nga muhang potential. So from this, we know that E is proportional to Q, given by this equation. We have this. So E is proportional to Q and V, right? Okay. E is proportional to V. Tungod ani nga tungod atong negative del V, proportional sa V, tapos E is proportional to Q by virtue of this. So we can arrange a constant of proportionality called capacitance given by this. So this is capacitance, ang imong ratio sa imong charge and potential. Oh, we already have solutions, wala pa questions. Okay, so unsay question ani? Nasa ko anig type. So ang question ani is, you find the capacitance of two concentric shells with radii A and B. So nakoy concentric shell. This is A and then this is B. So unsa kaha ang iyahang capacitance? In this case, we place the plus Q on the inner side. So this is plus Q ang iyang charge. So posin sila mga conductors, right? But arrange siya sandwich. And this is what we call capacitors. And a negative Q on the outer side. Now the field between the sphere is given by this. So by virtue of Gauss's law, right? Always ang Gauss's law, that's 4 pi r squared. Q enclosed is Q over epsilon naught. That's why we have this. So the potential difference between them is given by this. Okay, from A to B. So imo siya integrate where E is given by this. Substitute nimo siya, then you get this form. You just simply integrate this one, that's 1 over R, and we have this equation sa imong capacitance. So 1 over A minus 1 over B. So it is clear here that V is proportional to Q. So the capacitance, the capacitance is Q, you just have to divide Q over V. So this is V, right? Imo siya ibutang sa ubos, you get this form. Mo na imong capacitance. So this is a very interesting to note. If you have a capacitor nga concentric shell or sphere ang imong gamit, so if magkadako ang imong radius A and B, of course modako pa imong capacitance, which actually makes sense, right? But if ang difference niya is magkagamay pod, ang difference nila, meaning mahitabo magkagamay ang difference sa B and A. So magkaduol ang ilahang distance, right? So mudako po ang ilahang value sa capacitance, right? Which is make sense but yeah. So this actually the formula for capacitance for this system. Next question, how much work is required to charge up a capacitor to a final amount of Q? Okay. So charging actually is done by pulling the electrons from the positive and carry them to the negative plate because work is needed man para i-bring nimo ang negative to the positive, right? Okay, always man nga about pulling the electrons from the positive. So work is needed for you to do that. Okay, always ang electron will stay siya sa kung asa ang positive charge because they attract. So electrons from positive and carry them to the negative plate. So that's how you do charging sa imong capacitor. So suppose that at some intermediate stage in the process, the charge on the positive plate is Q, so that the potential difference is Q over C. Right? Because capacitance is Q over V, therefore V is Q over C. So thus, the amount of work you must do to transport the next piece of charge dq is like this. Okay, so you have dw, so it's like dq. So actually, medyo loose kayo siya nga pag-define sa imong work, but it actually works. Okay, in reality, pag-transport nimo sa imong charge, per charge man na siya actually. Wala siya ginatawag na kanang gamay siya ka charge because charge is quantized. This is quantized. But in this case, gi-assume lang nga continuous ang imuhang dq. But anyway, if you integrate this one, integrate nimo, you will actually get this formula. So that's a total work needed to go from zero charge to a total charge Q. Same mo, ang limit nimo is from 0 up to Q. Okay, mo make sense na po siya because we will actually get the right answer. So this is the work needed to charge up a capacitor to a final amount of Q. So that's 1/2 Q squared over C. And since Q is C over V, you can actually rephrase this work by having this formula. So pwede po 1/2 CV squared or pwede po 1/2 Q squared over C. If you know Q, you can get the work, or if you know the potential, you can get the work also. So let's consider this example. You find the capacitance per unit length of two coaxial metal cylindrical tubes of radii A and B. So inner radius of A and outer radius of B. So suppose the charge on the inner cylinder is positive Q for a length L. And so we can get the electric field sa kaninga case given by this. So to have 2 pi SL and then Q enclosed 1 over epsilon naught. And so we can get the formula for the electric field. Tara. So that's the formula for the electric field anywhere. Pwede sa sulod or pwede sa gawas. So this is generic, right? Because, okay, asa ang S? So actually na ano siya, we have your 2 pi. This is not actually epsilon naught, this is S. Okay. S na siya. So the potential difference between the cylinder, okay, you have this formula, then the electric field is given by this, you substitute, then you get this form. You can easily integrate this as 1 over, this is ln of S, right? So simplifying, evaluating this integral, you get this, ln of A over B. Now in this setup, however, this is VB minus VA. We know man nga ang kaning B is at higher potential, right? And then ang A nimo is lower potential. Where does it say? Okay, it says here sa so good, we assume na ang inner is positive Q and then ang outer is negative Q. So that's why nakaingon din nga A is at higher potential because it is positive Q and B is negative Q. So instead of having this, pwede siya balihon to get the potential difference. Okay, so instead of ln of A over B, then you get ln B over A. So that's why we have this. So that's the potential. And so we can get the capacitance calculated as Q over V, where makancel ang Q, we are left only with this equation. So that's 2 pi epsilon naught L, tapos ln of B over A. And then we can also immediately get the capacitance per length, capacitance per unit length given by this. So i-divide naman mo siya og C over L. Right? So i-cancel ang L. We only have this equation. So per unit length na siya. So that's it, class, for this topic, work energy in electrostatic. So we were able to successfully calculate, given the system, the energy configuration for that system, and then we also successfully calculated the electric field and also for the potential. So nahaman nata actually sa electrostatic ang topic covering electric field, potential, and then work, and then metallic conductors and capacitors. So next week, we'll be discussing on special techniques calculating the electric field and also for potential. That's it, and stay safe and God bless.